Welcome you all. Let us go to study analysis of truss. So in this problem, truss is given. So this is just for example, only two members are shown into the truss. So when this kind of truss is given, so in question there is always area and modulus of elasticity is given. If it is not given, then you consider. So I will just explain how to represent this truss. Truss is shown. Now represent the members. Number 1, number 2. So these are the two members, 1 and 2. These are truss members, or we say elements, or elements. Then length of first element, which is x. At the time of considering this length, we are representing this length by L or HE, and vertical distance is shown y. So by using formula, L is equal to xj minus xi bracket square plus yj minus yi bracket square. So using this formula we can calculate second member's length. So before calculating length of second member, we should go to prepare one table, and that table is, first we have to represent element number, then nodes, then coordinates xi, yi, xj, yj, length L, next is directional cosine small l, xj minus xi by L, next is small m, yj minus yi upon L, then L square, next is m square, and last column is Lm. So initially we should write all the inputs for this table, and after making table, then it is clear to write element matrix equation and how to put these values with directional cosines we will see. Element number. In this problem, total number of elements are 2. Element is truss member. So 1 and 2 already shown. So number 1 and number 2. Then nodes. Each element or each truss member is in between two nodes. These joining points are called as nodes. So I will write here two subcolumns which are represented by I and J. Now first give node numbers. Node number 1, this is joining point of first element. Node number 2, joining point of second element, and number 3, joining point of second element, but it is end point. Okay. So total number of nodes are 3. First element is in between. This element is in between node number 1 and 2, so I will write 1 and 2. Second element is in between node number 2 and 3. Similarly, I will go to write 2 and 3. Okay. Next is each member is shown in this figure, and after application of some forces, for example, force is applied at second node, I will write as P. This force is applied in downward direction at node number 2. So when we use finite element method to solve such a kind of problem. And if we see truss element, then at each node there are 2 degrees of freedom. At each node 2 degrees of freedom. So total number of degrees of freedoms are total degrees of freedoms are 6. How? At first node 1 and 2, next node 3 and 4, and at last node 5 and 6. So these are the degrees of freedom. Next, to write these coordinates, we should set node number 1 as origin. So generally lower left corner is selected as origin. So in this truss, this is a lower left corner, so I am selecting this node number 1 as origin. Node 1 as origin. So here I will write 0, 0. Now from this point we can write x coordinates and y coordinates for respective nodes. Now as we see in this table, nodes are ij, nodes for element number 1 lying in between node number 1 and node number 2. So these two nodes have been written 1 and 2, and second element lies in between node number 2 and node number 3, so here it is written 2 and 3. Coordinates of first node, as it is written xi and yi, I indicates 1, so we will write the coordinates for 1, that is 0, 0. Next is xj, yj. J is what? 2. So what is given? Coordinates of node number 2. xj, yj. J is 2. So coordinates for x and y coordinate for second node. What is the coordinate for this second node? X distance is, as it is given there, it is x, and yj is 0. Okay. In problem there will be some value like 200, 300, 500. So you have to write as it is, x distance and y distance. So these are the x and y coordinates. Okay. Similarly for second element, xi, yi. I for this second element xi, yi,